Hey everyone, I'm the development manager for a CICS Banking application, and I want to walk you through our zAdviser application analysis report. Not just the findings, but where each finding comes from, so you can follow along in the report yourself. This is a three-part analysis: an application architecture report, a deep program analysis on our most complex programs, and the zAdviser development telemetry analysis. Let me show what each one tells us. Starting with the application architecture report, Section 1 gives us the overview. This is a banking front office system: account creation, inquiry, updates, deletions, fund transfers, credit-debit. It runs across 32 programs, approximately 23,000 lines of code, with 27 CICS online programs, 11 programs with embedded DB2 SQL, and a single batch orchestrator. Section 2 gives you the high-level architecture diagram, and what it immediately shows you is how this application is structured as two distinct worlds: an online layer of CICS transactions handling every customer-facing function, and a separate batch orchestrator running nightly file and database operations. Those two worlds don't cross. That separation matters when you're thinking about where a change can go wrong. As the development manager, this diagram is the first thing I show a new developer on my team, because before you touch a single line of code, you need to understand what calls what and what breaks if you get it wrong. Now flip to Section 4, the component inventory. This is where you start to see the real picture. Every program listed with its lines of code, paragraph count, data field count, and cyclomatic complexity scores. A few that jump out: BNK1 DCS, our customer entry, delete, and update program. This comes in at a complexity score of 43, over 2,000 lines of code, and 177 data fields. One of our critical programs is the account update program, BNK1 UAC. It is over 1,400 lines of code with a complexity of 42. And finally, BNK1 CCS. The customer creation program has a complexity of 40. As the development manager, I have a better picture of the application, how big and complex each program is. Prior to the zAdviser application analysis, I only had what the development team told me and my gut feel when talking to senior leadership about this application. Let's jump to Section 7, Key Risks and Observations. The report explicitly flags that 10 of our 32 programs have complexity scores above 30. It also singles out BNK1 DCS as a single point of failure, highest complexity in the application, orchestrating 15 downstream calls. If BNK1 DCS has a problem, a lot of business functions feel it. As a development manager, this tells me exactly where my highest risk change requests are going to land. When a developer comes to me and says they need to touch BNK1 DCS, I'm not guessing at the impact anymore. I know it's the most complex program in the application, I know it has 15 downstream dependencies, and I know I need my best people on that work with full test coverage before it goes anywhere near production. Towards the end of the report, the zAdviser development telemetry data for the application is presented. This provides me with the operational picture for my application. The top programs by a bend frequency table shows 3 high-risk programs: BNK1CRA with 5 production abends and a mean time between failures of 432 hours, BNK1CAC and BNK1DAC each, with 4 abends. The top abend codes table tells us why. 38% of all abends are SOC 7 data exception abends with invalid decimal data. Another 24 are AEI 0 CICS task abends during map and data handling. Those 2 codes alone account for over 60% of our production failures. What this told me is that our production failures aren't random noise. They're a pattern. And a pattern is something I can actually put a plan behind. Now let's go into the deep program analysis, specifically for the program BNK1CRA, because this is where the report earns its keep. In BNK1CRA Complexity Assessment Section 5, we see there are over 1,100 lines of code, 20 paragraphs, a cyclomatic complexity of 41, 28 if statements, and 36 CICS calls, all in a single monolithic program with no separation between the UI layer, validation logic, and business rules. Section 2, the control flow analysis, shows me something important. The entire downstream path of this transaction is routed from a single entry paragraph. One logic error there, and the whole transaction misbehaves. And when it hits a critical failure, it issues an exec kicks a bend, a hard task kill. Section 2 explicitly notes there's no graceful exit and no audit trail. What I learned from this was if all routing flows from one entry point with no modular separation, we can't unit test individual pieces of this program. We can only test the whole thing end to end. Which means our test coverage numbers might be flattering, but we're not actually covering all those branches. Section 6, Modernization Notes, identifies the areas where we should strongly consider modernization, extract validation and data population into separate reusable modules, replace those hard ABIN calls with structured CICS error handling, replace the screen maps with a REST interface, and introduce automated test coverage using BMC AMI DevX Total Test. Normally, we would spend days in meetings, pulling senior developers together just to figure out where to even begin to modernize the application. Section 6 walks in with that agenda already written. Now we can spend that time actually having productive conversations instead of trying to frame it. And if you want to know whether the work we're already doing is paying off, look at the Development Productivity Analysis section. Our deployment frequency is up 41% over 3 months. Change failure rate is down 31%. Production abends cut in half. The trend is good, but the application architecture and deep program analysis sections show us exactly where technical debt still lives and precisely what to do about it. And here's what makes me proud of this team. Over the last 3 months, our deployment frequency is up 41%. Change failure rate is down 31%. Production abends cut in half. My team did that. But here's what this analysis gave me that the DevOps KPIs couldn't. It showed me exactly why some things are still hard. The complexity is in specific programs. The abends have specific root causes. The structural risks have specific names. The development data analysis tells me we're moving in the right direction. The application architecture and deep program analysis tell me how we stay there. That's the value of this report, and that's what we're going to keep building on.